Okay, so this is a repeat video because I had an arithmetic error in the original. Here we are looking at ways of interpreting moles and how mole ratios are worked with in balanced chemical equations. So in this equation up here, we have three copper chloride aqueous react with 2 moles of aluminum solid to produce 2 moles of aluminum chloride aqueous and 3 moles of copper metal. So we can interpret that balanced chemical equation in terms of mole ratios or in terms of molecule ratio. So we could say 3 molecules of copper 2 chloride react with 2 atoms of aluminum metal, or we could say 3 moles of copper 2 chloride react with 2 moles of aluminum. So let's look at the problem. How many moles of aluminum react with 5 moles of copper 2 chloride? What we do is generally we start with what we have. And so we are given that there are, and let's say 5.0 moles of copper 2 chloride. And they react in a 3:2 ratio with aluminum. So we're going to use our mole to mole ratio. Anytime we go from one chemical species to another, and we're talking about relationships, could be reactant to reactant, reactant to product, product to reactant, you have to use a mole to mole ratio. So if you started in mass, you'd convert to mole and then use the mole to mole ratio. So here what we're going to say is that 3 moles of copper 2 chloride react with 2 moles of aluminum metal. And so 5 times 2 is 10 divided by 3 is 3.3 moles of aluminum react with 5 moles of copper 2 chloride. And notice that the moles of copper chloride cancel, and what you're left with is the moles of aluminum. Okay, how many moles of copper can be produced from 5.0 moles of aluminum? And again, now we're going from aluminum to copper, and we will need the mole to mole ratio. So I'm going to start with what I have, which is 5.0 moles of aluminum. And now I'm going to use my mole to mole ratio. This is my starting material. And I need to cancel moles of aluminum, so I'm going to put 2 moles of aluminum on the bottom. And I'm going to copper, so I'll put 3 moles of copper on top. And so this is 5.0 times 3, which is 15, divided by 2. That gives me 7.5 moles of copper. And moles of aluminum cancel. What we're left with is moles of copper. And these mole to mole ratios, those are always integers, so these are considered exact numbers. We can keep 2 sig figs in our answer because our measured quantity is the number of moles, and that had 2 sig figs.